Hello, and welcome to the Digital Spiffy YouTube channel. This video is the fourth in a series covering the material on the CCNP ENCOR exam. I will be using physical Cisco equipment to lab the material. The lab material is sourced from the CCNP ENCOR Lab Manual version 8. I highly recommend reading the CCNP Enterprise Core 350-401 official Cert guide in conjunction with this lab material. This will provide a better understanding of the labs and what is occurring on the equipment. You can find links to these books in the description below. This video will complete the section on spanning tree by explaining multiple spanning tree protocol. MST is one of the three STP modes supported on Catalyst switches. Per VLAN Spanning Tree Plus provides a more tunable spanning tree topology compared to the original 802.1d standard, but PVST does have its limitations. In large environments that support thousands of VLANs, a switch would need to support an STP state for each VLAN, which can slow the switch's processor and impact network performance. Processing BPDUs for each VLAN doesn't scale. When a trunk link fails, a switch would have to calculate the route for multiple VLANs. Multiple spanning tree provides a solution in that multiple VLANs can be mapped to a single STP tree called an MST instance. A grouping of MST switches with the same STP configuration is known as an MST region. An MST region will appear as a single virtual switch to external switches to ensure compatibility. MST uses an STP instance called the internal spanning tree, which is always the first instance shown as MST0 on the switch. IST runs on all switch port interfaces for switches in the MST region, regardless of the VLANs associated with the ports. IST has a specific BPDU that includes information about other MST instances. This provides MST the ability to advertise only one set of BPDUs, thus minimizing the STP traffic regardless of the number of instances. By default, Cisco switches support up to 16 MST instances. Multiple spanning tree works very similar to rapid per VLAN spanning tree, except for a few commands. To put a switch in the MST mode, the command spanning-tree mode MST is used. A priority can be configured for each instance with the command spanning-tree MST instance number priority number. The priority value is between 0 and 61,440, and increments in values of 4,096, as the previous iterations of spanning tree protocol did. Just like with PVST, the root primary and secondary commands can be used to automatically set the priority based on the current root's priority. By default, all VLANs are associated to the MST0 instance, but using the command spanning-tree MST configuration, you can enter the MST submode and assign VLANs to another instance with the command instance number VLAN number. The MST version number is used to keep switches in the same region matching. This version number is configured with the command revision number and is set statically. This does not propagate to other switches, and each switch will need to increase its revision number with each change made to stay uniform with other switches. A region name can be assigned with the command name MST region name. Detailed MST settings for a specific interface can be viewed with the command show spanning-tree MST interface number detail. This will provide information about BPDUs. MST information can be displayed using the command show spanning-tree. This output will differ slightly from the other STP modes in that the VLAN numbers aren't shown and the priority value for a switch is the MST instance plus the switch priority. You can see a more tuned output for MST using the command show spanning-tree MST. The optional number can be included to only show output to a specific instance. Just like other STP modes, MST can tune ports with cost and port priority. MST uses the long cost for ports based on bandwidth. This provides more flexibility for larger bandwidth interfaces. The interface cost can be modified in the interface config with the command spanning-tree MST instance number cost number. Port priority impacts which port is an alternate port, when multiple links are used between switches. The decision about which interface to use is based on the lowest port priority, which defaults to 128.interface ID. The higher the port number, the less likely it will be the root port. The port priority can be modified in the interface config with the command spanning-tree mst instance number port priority priority number. Unlike other STP modes, the MST port priority doesn't have to be modified in increments of 16. An MST region boundary is any port on an MST switch that connects to a switch that is in a different MST region or a switch operating in a non-MST mode. Multiple spanning tree instances never interact outside the region. MST switches detect PVST plus neighbors at MST region boundaries and engage a feature called PVST simulation mechanism. This simulation mechanism sends out PVST plus or RSTP BPDUs for each VLAN using the information from the IST. This is required because non-MST topologies do not understand IST BPDU structure. When an MST boundary receives a non-MST BPDU, it does not map the VLANs to the appropriate MSTI. Instead, the MST boundary maps the PVST plus BPDU from VLAN 1 to the IST instance. There are two options when working with an MST region connected to a PVST or RSTP topology. The first option is that the MST region is the root bridge for all VLANs. The second is that it is not a root bridge for any VLAN. Before we begin working with the equipment in the lab, I want to cover the key terms we have just discussed. Common spanning tree. A single spanning tree instance for the entire network as defined in the 802.1d standard. MST instance. A single spanning tree instance for a specified set of VLANs in the MST protocol. Internal spanning tree. The first MSTI in the MST protocol. The IST is responsible for building a CST across all VLANs, regardless of their VLAN membership. The IST contains advertisements for other MSTIs in its BPDUs. MST region. A collection of MSTIs that operate in the same MST domain. MST region boundary. Any switch port that connects to another switch in a different MST region or that connects to a non-MST instance. PVST simulation check. The process of ensuring that the MST region is the STP root bridge for all the VLANs or none of the VLANs. If the MST region is a partial STP root bridge, the port is shut down. In the first part of this lab, we will set up the network topology and configure basic settings and trunks for VLANs. I've saved the configuration in a text file and uploaded it to my website, digitalspiffy.com. You can find links to download this and other related files in the description below. I'll start with configuring the D1 switch. In this lab, we will implement multiple spanning tree, but initially we are going to use the spanning tree mode rapid per VLAN spanning tree. I'll configure the console port to prevent it from timing out, as well as to keep the terminal output from typing over our command line. We can now configure our trunk ports that connect to the A1 switch and allow the VLANs used in this lab. The Gigabit Ethernet port 101 is a fiber connection that connects to the D2 switch. The D2 and A1 switches will be configured identical to the A1 switch with the appropriate port configs. So I'll just go ahead and paste that config in now. And we'll get our VLANs configured for D1 as well. The switches have been configured, interfaces are up, and the spanning tree mode has been set. Our next step is to set the spanning tree mode as MST on D1 and D2. We will do this so we can observe their interaction with each other as well as their interaction with the A1 switch. The MST mode can be enabled using the command spanning tree mode MST. Because we have not configured MST to anything specific, MSTI0 is the only instance and operational for all VLANs. We can see this with the command show spanning tree MST. You can see in the output of this show command that D1 and D2's interfaces, Fast Ethernet 101 and 102, are connected to a switch that is not running MST. Their type is listed as a P2P bound PVST. This means that a non-MST BPDU has been received on these ports. MST works similarly to spanning tree, where a root bridge must be selected, then root ports, and then passed to the root bridge from non-root switches. Currently, you will notice that D1 has been elected the root bridge. This occurred because the bridge priority is tied with D2 using the default of 32,768, and D1 has a lower binary converted MAC address. Using the command show spanning tree root on A1, you can see that there are 5 instances of spanning tree. This is because spanning tree mode configured is rapid per VLAN spanning tree. On D2, you can issue the same command, and you can see the output is different because with MST, only one instance of spanning tree algorithm runs by default. Now I will change the spanning tree mode on A1 to MST. Multiple spanning tree allows network engineers to reduce the load of spanning tree protocol while still providing unique spanning tree topologies for groups of VLANs. MST configuration must be completed on each switch individually. On D1, I'll configure MST using the command spanning tree MST configuration. Once in the MST configuration mode, you can set the MST region name using the command name, and I'll name this region digital spiffy .lab. I'll set the revision number for this config to 1, and then I'll add instance 1 with VLAN 2 and instance 2 with VLAN 4. In the MST configuration mode, we can issue the command show current and show pending to verify our MST configuration. I'll hit the end command and see our first MST configuration here with the command show spanning tree MST. MST does not propagate configuration changes to other switches. Each switch exchanges digest information summarizing the VLAN to instance mapping it has configured. If a switch receives a BPDU with different digest, it assumes the other switch is in a different MST region. On the A1 switch, you can see the ports connected to D1 are labeled with P2P bound RSTP. This is because the digest is different. Using the command show spanning tree MST configuration digest, you can see the difference between D1 and A1. On D1, we can modify the MST region to revision 2 and add VLAN 3 to instance 1 and VLAN 5 to instance 2. I'll do the show current command after entering the spanning tree MST configuration mode. This shows our current MST instances and the VLANs attached to them. And I'll now begin making the change with revision 2, and then I can add VLAN 3 to instance 1 and VLAN 5 to instance 2. We can now do the show pending command and see the pending MST configuration that we just added. Now I'll set up D2 and A1 with the same configuration. On D1, I'll run the command show run pipe begin MST to pull up our config and replicate the configuration to the other switches. Our region name is digitalspiffy.lab. Revision is number 2. Instance 1 has VLAN 2 and 3. Instance 2 has VLAN 4 and 5. After configuring A1, we can run the command show spanning tree MST configuration digest and verify the digest is the same on each switch. As discussed earlier, we established why D1 was elected as the root bridge, with the priority and system ID being identical. The root bridge's MAC address is a smaller converted binary number. With PVST plus or RSTP, the root bridge selection occurs for each VLAN, but with MST, it is with each MST instance. We can tune this by modifying the priority on the switches. On D1, we will use the command spanning tree MST1 root primary and spanning tree MST2 root secondary. With this command, the priority is automatically set. The primary option sets the priority to 24,576 by default. If the root bridge priority has already been statically set, this command will lower the priority 4,096 lower than the current root's priority. This means the root primary command lowers the priority only as much as needed to win the root election. The secondary option statically sets the priority to 28,672. You can do a little math and you'll notice this is 4,096 higher than the current root option. On D2, we will do the opposite and assign the MST instance as the secondary for instance 1. And the instance 2 as the primary. Running the command show spanning tree root on each switch, we can verify these changes have taken effect. As the network is implemented right now, there are 2 direct paths between A1 and the root bridge for each MST. Path and port costs are evaluated to determine the shortest path to the root bridge. In our lab, there are multiple equal cost paths to the root bridge, so additional attributes are used. Currently, the lower number interface is being used. On A1, using the command show spanning tree blocked ports, we can see the blocked interfaces for each MST instance. We can view the instance information with the command show spanning tree MST1, and you will notice that MST1 has the root port on Fast Ethernet 101. We can manipulate this by changing the port cost or port priority. So on A1, I'll shut down the Fast Ethernet ports that connect to D1 switch. And then on Fast Ethernet 102, can modify the spanning tree cost for MST1 using the command spanning-tree MST1 cost, and I'll set it to 1000. This is using the long mode. Let's bring the interfaces back online. Now we can verify the impacts for the root port on A1 using the command show spanning tree MST1 and show spanning tree blocked ports. From the output, you can see that the Fast Ethernet 102 is now the root port with a cost of 1000. As an additional method to impact the root port selected by A1, we can change the port priority on the root bridge itself. A1 has two connections to the root bridge, D2 for MST instance 2. The root port has been selected based on the lowest port ID. We've discussed that port priority defaults to 128.interface ID. This can be modified in increments of 16. On A1, I'll do the command show spanning tree MST2, and we can check the port ID values listed. We are using defaults, so Fast Ethernet 103 has been chosen as the route to the D2 switch. We can modify port priority on D2 interface Fast Ethernet 02, which connects to the Fast Ethernet 104 on A1. And first I'll shut the port down, and issue the command spanning tree port-priority, change that to 64, and then I'll no shut that again. So once it comes back up, we can check on A1, and now we see that the Fast Ethernet 104 is the root port. Thank you for watching the Digital Spiffy YouTube channel. This video is the fourth in a series covering the material on the CCNP ENCOR exam. In this video, we explored 802.1s, multiple spanning tree.